In this case, what we are taking is let E1 is equal to E2. That is, amplitudes are equal. Amplitudes are equal and theta is equal to plus or minus 90 degrees. Plus or minus 90 degrees. Then what happens? Or in general, theta is equal to plus or minus n plus 1 into pi by 2, where n is equal to 0, 1, 2. Theta is equal to either plus or minus 90 degrees. Then what happens to equation 1? Equation 1 becomes Ey by E2 whole square plus Ex by E1 whole square minus 2 Ex Ey by Em1 Em2. Cos 90 is 0 into 0 is equal to sin 90 1, sin 90 square 1. So irrespective of a plus or minus, it becomes, this term vanishes. So this implies Ex by E1 whole square plus Ey by E2 whole square is equal to 1. But what is the condition we considered? E1 is equal to E2. That implies Ex square plus Ey square is equal to, in general I am taking E1 is equal to E2 is equal to some E square. Ex square plus Ey square is equal to E square. What is this equation? This is Ex, this is Ey. If I draw a figure for Ex and Ey, this is nothing but equation of a circle. Equation of a circle with a radius E, with a radius E. So the resultant electric field is in the form of a circle. Therefore this equation represents a circle with the center 0, 0 and radius Em. Radius Em. So that we can say that this polarization is circular polarization, because the tip of the electric field traces a circle. So this polarization we can call it as circular polarization. Circular polarization. So what is the condition for circular polarization? Both magnitudes are equal and theta is equal to either plus or minus 90 degrees. Plus or minus 90 degrees. One more thing here interesting is, if theta is equal to minus 90 degrees, what happens? If theta is equal to plus 90 degree, what happens? Suppose if theta is equal to minus 90 means the negative angle direction, that is this direction, like this. This orientation, like this. Negative angle direction, negative angle direction. So if you observe this, this is rotation is like this. The rotation is like this. So to which hand we are coming towards right hand. We are coming towards right hand. So we can call it as right-handed circular polarization. Right-handed circular polarization. Suppose if theta is equal to plus 90 degrees. Plus 90 degrees means like this. Suppose this is a circular polarization, positive angle direction. Positive angle direction means this. So like this. That is positively we are coming. This is from 0 to 90 degrees. So the rotation is like this. That is, we are coming towards which hand? We are coming towards left hand. We are coming towards left hand. So if theta is equal to plus or 90 degrees, we can call it as the wave is left-handed circular polarization. Left-handed circular polarization. So these are two different cases for theta is equal to minus 90 degrees and theta is equal to plus 90 degrees. Amplitude is same. Amplitude must be same for both, either right-handed or left-handed. Only it depends upon negative angles. If theta is equal to minus 90 degrees, it is a right-handed circular polarization. If theta is equal to plus 90 degrees, the wave is a left-handed circular polarization. That is, A circular polarized wave looks like this in free space. It rotates like this. So circular rotation. Like this. These are nothing but like circles. Actually, circles. So it will rotate like this. The orientation of the wave is in the form of a circular wave. Circular wave. Helical antenna. The application is helical antenna. Helical antenna produces circular polarization. Helical antenna produces circular polarization, which is mostly used in military communications. Suppose this is a right-handed circular polarization. Suppose if the orientation is opposite to this, then it is a left-hand circular polarization. That is, the figure traced by the electric field vector is in the form of a circle. So we are calling it as a circular polarization. The third case is if E1 is not equal to E2 or E1 is equal to E2. Again it is independent of amplitude. For the first case, E1 is not equal to E2 and theta is equal to 90 degrees. Or this is a particular case. E1 is not equal to E2 and theta is equal to 90 degrees, or E1 is equal to E2 and theta is not equal to 0 or plus or minus 90 degrees. If you observe this, this is another condition. If you observe these two conditions, E1 is not equal to E2. So already we discussed linear polarization and circular polarization. E1 is not equal to means the only possibility is linear polarization only, because in linear polarization amplitude is independent. So E1 is not equal to E2 and theta is equal to 90 degrees here. But for linear polarization theta is equal to 0 or 180 degrees. So this is a different case from linear. If you come to this, E1 is equal to E2. E1 is equal to E2 means definitely it is a circular polarization. But here if you observe, theta is not equal to plus or minus 90 degrees or 0 degree also. Because E1 is equal to E2, it is also possible for linear and circular. But I am awaiting the phase conditions. So these two are nothing but not linear and not circular. Some other case. Then what happens? Then equation 1 becomes Ex square by E1 square plus Ey square by E2 square is equal to 1. I am taking theta is equal to 90 degrees, cos 90 is 0, sin 90 is equal to 1. Even if you consider this case, the equation 1 remains as it is, because theta is some different angle, so it has some values. So the equation 1 has this type of form only, but additionally we will get some Ex, Ey term also, which is nothing but a ellipse equation. Suppose if you observe this equation, Ex square by E1 square plus Ey square by E2 square is equal to 1, which is nothing but an ellipse. Equation. It is nothing but an ellipse equation. That is, the resultant shape is like this, in the form of a ellipse. So this is like this, OP, OQ. So this is major axis, this is minor axis of the ellipse. Axial ratio means major axis OP by minor axis OQ. Suppose for circular polarization, what is the thing? Circular polarization means like this. Major axis is equal to minor axis. For circular polarization, what is the axial ratio? Axial ratio AR. Axial ratio is equal to 1. Similarly, for linear polarization means like this. Minor axis is equal to 0. Minor axis is equal to 0 means what is axial ratio? Axial ratio is equal to infinity. For elliptical polarization, there is a finite value of axial ratio. Therefore, 1 less than or equal to axial ratio less than or equal to infinity. This is the range of axial ratio. Range of axial ratio. If you observe this elliptical polarization, both linear polarization and circular polarizations are special cases of linear polarization only. Special cases of elliptical polarization only. That is, if this major axis and minor axis are equal, that is as this ellipse is expanding at a particular angle, both major axis equal to minor axis, then it becomes a circular polarization. As this major axis is reducing at a particular angle, it becomes linear only. What is that angle? It is either theta or 180 degrees or generally plus or minus n pi. So we can say that both circular polarization and linear polarizations are special cases of elliptical polarization only. Elliptical polarization only. So this is the condition. What is the condition? Condition is either the two magnets are not equal and theta is must be 90 degrees. E1 is equal to E2. Magnets 2 are equal, but theta is not equal to 0 or theta is not equal to plus or minus 90 degrees. That is except linear condition and except circular condition. Remaining all cases is nothing but a elliptical polarization. So the conclusion here is both circular polarization and linear polarizations are special cases of elliptical polarization only, which is very, very important. One more thing here is, suppose the angle is theta. If theta is positive, then we can call it as left-handed elliptical polarization. Left-handed elliptical polarization. If theta is negative, we can call it as right-handed elliptical polarization. Left-handed elliptical polarization. For theta negative, right-handed elliptical polarization, which is a similar case of circular only. See some problems on polarization. The first problem is problem 1. The electric field of an electromagnetic wave or EM wave propagating in the positive z direction is given by E is equal to ax cap sin omega t minus beta z plus ay cap sin omega t minus beta z plus pi by 2 plus pi by 2. The wave is option A, linearly polarized in the z direction. Option B, elliptically polarized. Option C, left hand circularly polarized. Option D, right hand circularly polarized. So solution to this problem is here the electric field is given. E is equal to ax bar sin omega t minus beta z plus ay bar sin omega t minus beta plus pi by 2. So if you observe this with the standard E, because the wave is propagating in z direction. What are the amplitudes? The E1 amplitude is 1. E1 amplitude is equal to 1. Similarly, what is the amplitude E2? E1 is equal to 1. E2 is also equal to 1. What is the theta? Theta is equal to pi by 2. Theta is equal to pi by 2. So here E1 is equal to E2. Amplitudes are equal and theta is equal to pi by 2. If amplitudes are equal, what are the possibilities? Only we have two possibilities. One is either linear polarization or another is circular polarization. One more thing, here theta is equal to pi by 2. Theta is equal to pi by 2 means definitely it is a circularly polarized wave. But here theta is plus pi by 2. That is in this direction. That is, if you are rotating like this, it comes towards the left hand side. So we can easily say that it is a left hand circularly polarized wave. Left handed circularly polarized wave. So option C is correct. Option C is correct. Generally in the examination we can expect this type of questions from polarization concept. Second problem is, a plane wave is characterized by E bar is equal to 0.5 x cap plus y cap e power j pi by 2 e power j omega t minus j kz. The wave is option A, linearly polarized. Option B, circularly polarized. Option C, elliptically polarized. Option D, unpolarized. The solution to this problem is, write down what is the amplitude E1 and E2. It is very clear, the x component, that is Ex component amplitude is 0.5. So E1 is equal to 0.5. Ey component, y bar component, Ey is equal to 1 or E2 is equal to 1. Then what is the angle theta? Theta is equal to, because here Ey component is multiplied by j pi by 2, because e power j omega t minus j kz is common to both Ex and Ey. The additional thing is only it is multiplied by Ey component is multiplied by e power j pi by 2. So additionally we are getting plus pi by 2. So theta is equal to pi by 2, that is 90 degrees. Here E1 is not equal to E2 and theta is equal to 90 degrees. E1 is not equal to theta is 90 degrees. So E1 is not equal to, if theta is equal to 90 degrees, if theta is equal to 0 or 180 degrees, then it is a linearly polarized wave. For circular polarization, E1 must be equal to E2. So definitely E1 is not equal to E2 and theta is equal to 90 degrees is a condition for elliptically polarized wave. So option C is correct. This is a elliptically polarized wave. So option C correct. Another problem is problem number 3. The electric field E bar is given by E naught e power j omega t plus beta z ax cap plus ay cap into the polarization is option A linear, option B elliptical, option C right-handed circular polarization, option D left-handed circular polarization. So this is very simple. If you observe the amplitudes, Ax component and Ay component amplitudes, both are same. E1 is equal to, E2 is equal to E naught. What is the phase angle difference? There is no phase angle difference. Both are in same phase. Both are in phase. So theta is equal to 0. So E1 is equal to E2, theta is equal to 0. What is the polarization? Simply we can say that it is a linear polarization. Linear polarization. So option A is correct. So generally this type of questions we can expect in the examination from polarization topic. Particularly they will give a wave equation and they will ask what type of polarization it is. So just we have to compare the amplitudes and the phase angle.